So our next topic that we have to discuss is something called CIDR. Now, CIDR is not something that we drink in networking, but it stands for Classless Interdomain Routing, CIDR. Now, we talked about class full routing. With class full routing, we have Class A, Class B, and Class C IP addresses, and their subnet masks are default for those particular IP addresses. So in class full IP addressing, any IP addresses which are in the Class A range have the subnet mask of 255.0.0.0. Any IP addresses in the Class B range have the IP address of 255.255.0.0, and any IP addresses in our Class C range have the address of 255.255.255.0. Now, there's another topic that we need to discuss, again, called CIDR. And what this does is it allows us to have variable length subnet masks. So when we're using CIDR, it means that we have subnet masks which aren't in those standard classes. Now, this will come in especially useful when we're talking about subnetting in a little bit. But CIDR notation is seen as a slash and then a number, and that number corresponds with a subnet mask. Now, why do we use CIDR notation? Well, we use CIDR notation because sometimes our standard subnet masks aren't going to work for us. We need to have some way of breaking our IP addresses, breaking up our network ranges into smaller subnets. And we can't do that with our standard subnet masks, with our standard class full addressing. Now, it's important to keep in mind that we need to understand the limitations of certain devices on our network, such as routers, to understand if they can do this classless addressing. Most of our modern devices on our network we're going to see today are able to do this. But classless addressing allows us to break up our subnet masks and work with our IP addresses so we can make the most use out of them. We talked about how our Class A, there's a large difference between our Class A, Class B, and Class C networks as far as how many networks versus how many hosts there can be on each network. And sometimes we need to be able to adjust that, and that's where CIDR comes in. Now, we display CIDR as a slash followed by a number. Now, this number can be anything from 1 to 31. So what does this number mean? Well, this number, the /n, is our prefix. Now, what we mean by prefix is when we break our subnet mask into individual bits, that number is the number of those bits starting from left to right that are ones. Now, when we're talking about our subnet masks have to be contiguous ones from left to right. We can't have a break with zeros in it, and we can't go from right to left. Our subnet masks have to go left to right, and there cannot be zeros in between ones. It just has to be straight ones until we stop. So our subnet mask of /16 would mean that we have 16 in a row straight ones. So let's take a look at that in our binary. Now, we know from our earlier lessons that an IP address, an IP version 4 address, is a 32-bit address, which means it has 32 ones or zeros. Those 32 ones or zeros are broken into 4 groups of 8 called octets. 4 times 8 equals 32. And those octets make up the numbers in our IP addresses or our subnet masks. So we have our -16 here, shown as 11111111.11111111. That's 16 straight ones. Now, just because we have a /16 doesn't mean we can excuse our dots in between our octets. We don't write 16 straight ones and then a dot. We still have to break up into octets. So we have 8 ones and then continue on with 8 more ones, and 8 plus 8 is 16. That's how we get our /16. So we've talked about how we translate binary into our numbers before, but how do we translate this binary, again, into our subnet mask via standard numbers? Well, let's take a look. So we drew out our binary here, our 16 ones followed by 16 zeros, because we have /16, and the /16 refers to our 16 ones that go left to right. And we also drew out our chart. Now this chart corresponds with each of our octets. We've talked about how binary increments by increasing powers of 2, starting with 0 to 1, 2, 4, 8, 16, 32, 64, 128. Because a binary digit can only be a 1 or a 0, corresponding with an electrical signal of an on, a 1, or an off, a 0. And our computers, at their very base language, talk in electrical signals, ons and offs. So we have to translate those to numbers so we can write applications and develop programs that can talk down to that. So how do we translate these ones and zeros into standard numbers? Well, again, we draw out our chart and we line up our chart with our octet. So we have our first octet here, and I can tell you right now that if you ever see an octet that is all ones, that octet is 255. An octet with all zeros is 0. But let's actually take this and dissect it out in order to understand why an octet with all ones is 255. So we have our chart, and in our first place indicates whether it's a value of a 0 or a 1. But again, our subnet masks are going to go from left to right. First place will indicate a 0 or a 1, a 0 or a 2, a 0 or a 4, 0 or 8. You get the idea. 16, 32, 64, 128. If you're doing an exam, you're taking a test, or maybe you're just trying to learn subnetting better, it's a good idea to have this chart already written out for you. It's good if you can get like a little whiteboard so that you don't have to constantly be erasing and scribbling out pencil or rewriting the chart in pen, and just get your whiteboard and practice this over and over and over in order to become very familiar with these numbers. So we have our chart here, and we have all ones. So we fill out our chart with our 8 ones. Now in binary, or when we're doing our IP addresses and we're translating from binary to our standard numbers, we now take every place that has a 1 in it and add it together. So we end up having 128 plus 64, which is going to give us 192. Then our 192 versus 32, which is going to give us our 224. 224 plus 16 is going to give us 240. 240 plus 8 is 248. 248 plus 4 is going to be 252. Sorry, that took longer than it should have. 252 plus 2 is going to be our 254. And 254 plus 1 is going to give us our 255. That's why our standard subnet masks, the highest number that they can be, and also in IP addressing, the highest number a single octet can be is 255. Because if all of those ones in the octet, or if all of the bits in the octet are ones, the highest number that can add up to is 255. So we have our 255. And then our second place, again, is all ones, so it's also 255. So this -16 is just 255.255.0.0. If it was a Class B address, this would be its standard subnet mask. So this was an easy one. This was an easy one to get started. If we see our CIDR notation in dash increments of 8, then we know that because it's in an increment of 8, we're just going up the chain and adding additional 255s. So, for example, a -16 would be equivalent to a 255.255.0.0. A -8 would only use this first octet and then have the rest zeros, so that would just be 255.0.0. And then a -24 would be 255.255.255.0. Now we can't have a -32 because as our subnet mask, because that's not going to leave us any room for hosts. A -32 would be 255.255.255.255, and that would mean that our entire IP address is the network ID, thus giving us no room for hosts. So we're not going to see a -32 CIDR notation for subnet mask. Now, those are easy. Those increments of 8 are easy, but they're a good place to get started at to understand how CIDR notation works. Let's do one that's a little bit more tricky. Let's take a look at -12. So I have question marks there because we don't want to make it too easy for everybody. So let's go ahead and erase our chart here, or erase our chart right here, and move over to our other side of the board and see if we can dissect this out. So we have a -12 CIDR notation prefix. So what that is telling us is we have 12 ones as our prefix for our subnet mask when we're translating it into binary. So we have 12 ones in a row. So let's go ahead and write everything out. So we have 1, 1, 1, 1, 1, 1, 1, 1. It's 8 ones. Then we have 4 more ones. So we have 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4. Now we don't just put another dot there, we have to finish out the zeros there. So we have to finish out the octet. So we write 4 more zeros, and then everything else is 0. Because we know that our first octet is all ones, we automatically know that, okay, an all ones in an octet is 255. So that's the easy one. We also know that all zeros equals 0. So those are also very easy. But what about this second octet here? How do we need to actually do our equation, and we need to break out our chart in order to figure out, okay, what is this second octet then? Let's go ahead and break out our chart. And we have our 128 place, 64, 32, 16, 8, 4, 2, and then 1. Now, if you know that 128 is going to be your highest, you can just start with 128 and then go backwards to 1. That's just easier for me. But when you're first learning and you're first creating these charts, to avoid not putting the correct numbers or not putting enough, you may want to start with 1 and then increment your way up going to 8 places. So instead of going backwards or highest to lowest like I did, you could go 1, 2, 4, 8, 16, 32, 64, 128. Just by habit, I go from 128 down. Now we take our second octet here and we just simply fill in our chart. So we have 4 ones, 1, 2, 3, 4, followed by 4 zeros, 1, 2, 3, 4. So now we just do our math and we figure out what number this is. We start with 128 and add 64. And that's going to give us 192. 192 plus 32, and that's going to give us our 224. So 192 plus 32 is going to give us our 224. And our 224 plus our last one here, 16, is now going to give us 240. So we don't add any of the rest of our values in this octet because they're all zeros. So if we wanted to, we could write out plus 0, plus 0, plus 0, plus 0. But it's the same as just finishing at our 240 and saying that's what our octet is. Now, if you were dissecting a standard IP address, then you would want to make sure you went all the way to the end, because an IP address could have another 1 in one of these additional places. CIDR notation is only ones from left to right, and then it'll stop, and then it'll be zeros. The same with our subnet masks, because our CIDR notations represent our subnet masks. So our final answer is going to be 240, and yes, that is my final answer. So our subnet mask, a -12 prefix, if we translated it into a standard form subnet mask, would be 255.240.0.0. So why do we use CIDR notation? Why don't we just write out everything as 255.240.0.0 or whatever our CIDR notation comes out to be? Well, CIDR notation gives us a little bit more, it saves us a couple steps per se. Say if we are writing out an IP address and we are modifying or adjusting the amount of bits in that subnet mask, so instead of writing it out as our standard subnet mask, we just write it as -12. That saves a network engineer, that saves us from having to say, okay, well, 255.240.0.0, let me break out my chart and let me take my chart and I'll go in and I'll take this and I'll translate it back to the binary and count out the ones and oh, that's a -12 prefix. It's easier to work with CIDR notation when we're working with subnets, which we'll talk about in a little bit, because it tells us the exact number of bits right away. It's sometimes easier to work with CIDR notation than it would be to work with our standard subnet mask in the actual number form. Also, it gives us a way that we can write things shorthand. We don't have to write out our, if we were writing out an IP address, we wouldn't have to write out, okay, this IP address is 192.168.1.15 with a subnet mask of 255.255.0.0. We could just write out, okay, this is this IP address is 192.168.1.15/16. And we'd be using CIDR notation. Or if we were using a standard subnet mask for our class 3 address, 192, a -16 on this address would be doing subnetting, which we'll talk about in our next module. But if we were using our standard class 3 or class C subnet mask for 192.168.1.15, we would just be putting our -24. And a -24, if you understand CIDR notation, you say, okay, 24 is an increment of 8, 8, 16, 24. That equals to 255.255.255.0. And the more you work with CIDR notation, the more you work with networks and IP addresses and subnet masks, the more you'll come to identify those. So you see the -12, and this, because this may have been the first time you've looked at it, you had to do the math. You had to break it down into your chart and say, okay, that means 255.240.0.0. But after you see -12 20 different times, then you immediately go, okay, -12, that's 255.240.0.0. And you save yourself some writing by just writing it out CIDR notation. So CIDR notation, we need to understand because we're in Network Plus and we're working with networking and working with IP addressing, and it's very critical to understand how CIDR notation works, especially moving on into subnetting.